To review power series. This is 6.1. Couple things that you should know going into 6.2, right? So we're going to find interval and radius of convergence. And let's do it for this power series here. Okay, now just to go over a couple things, like this notation here just means it's the sum of all the values after you plug in. So you're starting to plug in 1 for n, then 2 for n, then 3 for n, and so on. So this series is going to look something like this. Like if I plugged in 1, right, I would get x minus 3 over 2. Plus if I plugged in 2 for n, so I would have x minus 3 squared over 2 squared times 2. And then that continues, plus x minus 3 to the third over 3 squared times 3 now. No, I'm sorry. 2 to the third times 3, my bad. Okay, over 2 to the third times 3, and so on. And that continues on infinitely. Now, if we're looking for the radius and interval of convergence, we want to use the ratio test. Okay, so now the ratio test looks like this. If you're taking the limit as n goes to infinity, and it's n plus 1 over n, a sub n, right, in absolute value. So if you see it alternate, you don't really need to be concerned, and that's going to give you some limit. Now, a couple things. If the limit is greater than 1, it diverges. Limit is less than 1, converges, and equal to 1, it's inconclusive. Okay. And a couple other things is you kind of want to know the harmonic series when you guys are doing this, right? So alternating would look like this, negative 1 to the n over n, something like that. And this converges. But if it doesn't alternate, right, it diverges. And that's important when you want to check endpoints. So let's go back to this series that we have up here, okay? And let's find that interval and radius. So first thing is, right, what is a sub n plus 1? That means you're just putting an n plus 1 everywhere you see an n. Okay, so now if we do the limit, if we do our ratio test, okay, limit as n goes to infinity, so a sub n plus 1 over a sub n, so that's your original series. And then this is going to equal, right? Remember your rule, keep and then flip the denominator, so you have 2 to the n times n over x minus 3 to the n. So a couple things you can do. You could start canceling out stuff, right? So you cancel out this x minus 3 to the n. You're left with 1 on top there. 2 to the n, you're left with 1 on top there. And then we have that limit. Now notice the limit is only when n is approaching infinity. So you could write this as x minus 3 times the 1/2, and then take the limit as n goes to infinity of n over n plus 1. So this limit here, right, when n goes to infinity, is going to be equal to 1, okay? That's because your degrees are the same. And now we just get an x minus 1, sorry. So we wind up with 1/2 x minus 3. All right, what do we want? We want that absolute value to be less than 1. So we know -1 is less than 1/2 x minus 3 is less than 1. So -2 is less than x minus 3 is less than 2. So our interval is going to be from 1 to 5, okay? But one thing that you want to do is you want to check the endpoints, right? So you got to check these two endpoints. So you're going to plug that back into the original, which is right here actually, right? And you want to see, is it alternating harmonic or harmonic, or is it one of those nice series like maybe a P series, something like that? Okay, so at this point I'm going to plug in 1. So when n is 1, actually when x is 1, sorry. So when x equals 1, I'm going to get 1 minus 3 to the n over 2 to the n times n, right? And this gives me -2 raised to the n over 2 to the n times n. And if you notice, those 2's will cancel, and we just wind up with a -1 to the n over n, and we know this one converges. So we're going to include the 1. Now if you plug in x to be 5, all right, we would get 5 minus 3 to the n over 2 to the n times n, and then this one will get 2 to the n over 2 to the n times n, and that's just going to be 1 over n. This one diverges, so we do not include the 5. So your interval is going to be 1, and you could write it like that notation, or you could do the 1 up top, to 5, and you don't want to include 5. So bracket on 1, parentheses on 5. The radius is real simple. Okay, think of that on the number line, 1 to 5. You could think of that the easiest way, 1 to 5, and what's your middle value? Okay, so the middle value here, right, would be what? 3. And then what is the distance? Okay, and that would be your radius, so 2. Easiest way to do it, what are your endpoints? 5 minus 1 divided by 2, so this gives me 4 over 2, or 2. So my radius of convergence will be 2. So your interval is 1 to 5, your radius is going to be 2.